If you guys have any doubts or questions on the previous sessions or anything like that, feel free to comment right now. We can have a quick discussion in the next 2 minutes before we get started with the proper content. My feeling was that it's getting a bit too frequent, these sessions. So we might dial down the frequency a bit because it's a bit troublesome for people also to like sit on Facebook every day and watch a video for somebody ranting along. Okay, we'll get started. We'll see if more people tune in and if there is any, we need to change something accordingly. So today we plan to do number system. I plan to cover the entire thing in three sessions. In general, the first session will be more basic than the second one, which will cover different topics, but also be a bit more we'll have more difficult questions, and then in the last session we'll do more difficult question as well. But even today we have good content to cover, probably the most relevant content to cover for cat perspective, because questions mostly come from here. What we'll cover today, what I have noticed, they don't come from finding remainders using remainder theorem and all that kind of stuff. There have been very few questions. We spend a lot of time practicing it, but in terms of questions that come in the exam, I don't think a lot of them do. So what we cover today is important from that perspective. Simple stuff which can be made into complicated questions, and we will look at some examples of the same. So let's get started. I'll get started with divisibility rules. I'm aware that some of the side part of the screen is getting cut off, so I'll try and manage that. So this stuff, most of you probably know this, so we won't spend a lot of time explaining it to you. We'll very quickly look at the question, but just very quickly, we can go through this. So how do you know whether a number is divisible by 3 or 9? The sum should be divisible by 3 or 9. For 4, 8 and 12, if the last two digits are divisible, then it's divisible by 4. So it's divisible by 4. And 8 and 12 accordingly, you know, like for 8 it needs to be last 3 digits. 12, sorry, won't be in the same pattern. I have misplaced it here. So 12 actually should not be here, but 8 would be last 3 digits. And the way you come up with this is it's last 2 digits by 4, because, and the reasoning is a bit good to know. A lot of people don't know the reason why it is that case. It's because if you have like 324 or something, you can break it down into 300 plus 24, and 4 divides 100. So any number which has 2 zeros at the end will be divisible by 4. So this number is divisible by 4. So as long as the last two are divisible by 4, the entire number will be divisible by 4. And same goes for 8. If you have a number which is 1, 2, 3, 5, it can be written as 1000 plus 235, and 8 divides 1000. So 235 is the only number which will determine whether the number is divisible by 8 or not, and that's why we take the last 3 digits. So that's how you determine whether it's divisible by 5 or 0. If you have 5 or 0 at the end, then it's divisible by 5. 6 and 12, you need to check for 3 and 2 or 3 and 4. So if it is divisible by 3 and divisible by 2, then it's divisible by 6. If it is divisible by 3 and divisible by 4, it's divisible by 12. 11 is a slightly different one. A lot of you know that already, still we'll just cover it. If we had to say 121, it's divisible by 11. The test is you take the numbers in odd positions and take the numbers in even positions, sum them up, take their difference, and that should be divisible by 11. So here it will be 2 minus 2 equal to 0. So that is divisible by 11. Let's take something bigger. So if we had to determine whether this number is divisible by 11, what we'll do is we'll take the numbers in the even positions and the odd positions separately. So this becomes 4 plus 2 plus 6 plus 1, 7. This becomes 5 plus 2, 8 plus 1, 9. 9 minus 7, 2 is not divisible by 11. So this number is not divisible by 11. And that you can check with any number which you know to be divisible by 11. So this is the test for divisibility for 11. Nothing very fancy there. We'll do a question. So this is the kind of question that comes in the exam. You can have very easy concept, simple to use concept, but the questions will be put in a way that you might get confused during the exam, or you might find it a bit difficult to go through it, solve it during that exam. So just let's look at it. So here what the question is saying is, if C is a positive integer, how many 3-digit numbers ABC are there such that both ABC and CBA are divisible by 4? So C is a positive integer, doesn't matter. I think all three will have to be positive integers. How many 3-digit numbers ABC are there? So we want ABC and CBA to be divisible by 4, right? The test for divisibility by 4 is that the final two numbers should be divisible by 4. So BC should be divisible by 4 and BA should be divisible by 4. And we have to find how many such numbers are possible. So let's see. If B is an odd number, if B is 1 or 3 or 5 or 7 or 9, what can C or A be, right? If it's 1 or 3, it has to have 2 or 6 as the next number. 12 and 16 are divisible by 4, or 32 or 36, 52 and 56, 72 and 76, 92 and 96. So only if it has 2 or 6 in the second place would it be considered divisible by 4. Same way, if B is even, which is 2, 4, 6, 8, or even 0, then the only way it will be divisible by 4 is if the next number is either of 0, 4, or 8, right? 20, 24, 28, 40, 44, 48, 60, 64, 68. For these three, it will be divisible. But 0 we cannot consider because it's a 3-digit number. So A or C cannot be 0. So 0 we have to eliminate. So for odd B's, there are two numbers which A or C can take. So total number of ways is 2 into 2. Like C can be 2 or 6, and same way A can be 2 or 6. And same way for even also there are two options. So it can be 2 into 2. And hence the number of ways would be 5 odd options for B. And for all 5 odd options, there are 4 answers, plus 5 even options. And for all 5 options, there are 4 options. So total number of ways will be 40. I'll take a pause here. Let me know if you do not follow, if it's a bit too rushed or something like that. I just read Deepak's comment that this event should be held twice or thrice a week. Deepak, also look at the number of viewers. Like it has like 5 people or 2 people. Then it can't only be run for 1 or 2 people. But if there are like 8-10 people interested, I'm happy to do it at least twice a week. Thrice, I'm not sure how we'll manage. But one weekend, which is the Sunday evening, I have definitely booked for quant classes, and we'll do some DI and verbal stuff in between. So yeah, we will do at least twice. I think I just lost some of your... So this is how the question has been solved. Also, please keep letting me know if you lose my screen. I'll adjust it accordingly. To improve the resolution on Facebook, I had to cut a bit of my screen, so there might be some parts which are missed out here and there. Just make mention and I'll move it around. So if there are no questions, if you have understood this one, I'll move to the next. I think I'll move ahead. And if you can revise, always revise the video. And if you need later on, if you have some questions, you can always ask them later on as well. So squares and cubes, one important thing which I have to say is in general, and we have commented on that also, I'll repeat it again and again, all that mumbo jumbo about Vedic maths, it helping you calculate faster and all that kind of stuff is crap. We cannot put it in more politically correct terms. We think it's a waste of time. If you have a lot of time, you can go ahead and study all that. It won't help you much because, and the reason why we say that it will give you a faster way to do some calculation, and even if that calculation comes, it's pretty straightforward. If you can do the faster way, but even the slower way, it will help you like 20 seconds. It will save you 20 seconds in the exam. You can always save 2-3 minutes just by approaching a problem in the correct manner. So we don't think there is much value to add there, and I won't cover it here. If you're very interested, go ahead and look at it. I think it does more harm than good. But to increase speed and to solve more questions, you should learn these things. So learn squares till 1 to 40. It's important, and the reason why it's important is not because it helps you solve questions quickly. You can multiply even this and get the answer, but the reason why many a times you'll be able to spot things if you have learned the squares properly. If you see 576, it strikes you that it's 24 square, and then you start thinking along those lines. So that's why I would recommend you go up till 40. It's not a lot of them you would know already, so do that. Cubes you should know till 20. It might be a bit of stretch. 1 to 10, 15 should also work, but it's not very difficult. At least have a look so that you can recognize that this looks like a cube number, especially for the prime numbers and the odd numbers. Even once you can still factorize very quickly in the exam and know. So try and spending some time and learning this stuff. I think it is very helpful in solving questions, not only in increasing speed. So this is, I think, important. The other part, just let's look at the square thing, because questions are created on this kind of stuff. The square of any number with a unit digit of 1 would have 1 as the unit digit. A lot of you again know this, but we'll still go through it fairly quickly. Square of any number with unit digit of 2 will have 4 as the unit digit. So 22 square, the unit digit will always be 4. If it has 3 on the unit digit, it will be 9. 4 again 6, and so on. You can check. So the square 6 has 6, 7 has 9. So overall what you get as a result is that only 0, 1, 4, 5, 6 and 9 can appear as square numbers. Like if a number is of the form 383, whatever, I can make something up. So this number cannot be a square number, that we know, because you cannot have 2 at the units digit. Questions are created on this kind of stuff, so it is good to know. Similarly, you can't have 7, 8 or 3 over here. It has to be some of this. And we'll see some questions on this also, but you should at least now you have heard it, so you should not forget. You should know these numbers and imbibe this concept that whenever a number which has like 3 at the end or 8 at the end cannot be a perfect square, because the unit digit does not match with what it should be. So again, this one I would recommend learning. I told you we are against Vedic maths, but we are not against everything which is taught in coaching institutes. I think this one is a bit helpful again. Learning fractions up till 1 by 30 might help you solve questions quicker, because the application is fairly broad based. When I had my coaching at Career Launcher, there was only this part which the teacher spent 10-15 minutes teaching, was the only useful part of the entire coaching experience, which ran into like 1.5 years. He had only this 15 minutes were useful. So I'll try and replicate what he did, and hopefully you would be able to get a bit of help from that. He tried to help us memorize it by some rules and stuff which he had created, and I'll repeat the same. It helped me learn all this stuff, because I'm very bad at memorizing things. So hopefully you will also be helped a lot bit, and then we will see how we can apply this stuff. So the first few are relatively easy, so you can remember that. Then 1 by 7 is 14 and 28, 14 and 28%, and 1 by 14 is 7 and 14%. So you can learn it this way. 1 by 8 is again relatively simple, 12.5%. 1 by 9 is 11 and 1, and 1 by 11 is 9 and 9. So that way again it's sort of easier to remember. 1 by 9, 11.1%, 1 by 11, 9.09%. Then 1 by 14, just a second. So the other thing which I remember fairly well, so 1 by 10 you can remember, 1 by 12 is still relatively easy, 8.33. 1 by 13, I did not remember exactly what he told, how to remember this one. But then there were a few more here and there which helped. So 1 by 17, and it's very surprising how our mind works. He said, just remember it like 1 by 17 is bus number 588. Now, I have never known what bus number 588 is, but 10 years from that experience, I still remember 1 by 17 is 588. So 5.88%. Hopefully, you will also remember 1 by 17 is bus number 588 or 5.88%. 1 by 19 is 5.26%, which is 0.26 ahead of 5. And 1 by 21 is 4.76, which is roughly 24 behind 5. So that way you can remember a bit ahead and a bit behind, about 0.25 decimal points. So 1 by 19 and 1 by 21. Same way with 1 by 25. 1 by 24 is around 16 points ahead, 4.16%. 1 by 26 is around 15 points behind, which is 3.85%. 1 by 27 is 3.7%, and 1 by 37 is actually 2.7%. So this helps memorize this. So this way, hopefully you got some part. 1 by 8 and 1 by 16 will be half of each other. So 1 by 8 is 12.5, 1 by 16 is 6.25. 1 by 15 you will have to remember. I did not have any, but 1 by 18 was again 1 by 11 you remember 9.09. 1 by 18 can be half of it. So 1 by 9 is 11.1. So 1 by 18 is half of it, which is 5.55%. So I would recommend that you try and memorize this. It might help you solve quickly. The reason why it might help you solve quickly is because many a times you're exposed to such stuff where there is a fraction at the bottom and you need to quickly go through some calculations, and it gives you some sort of a quick method to just get the number wherever it is. We'll just quickly try and see a couple of examples. So this is 5 by 7. So if you wanted to know the decimal place, one way you should do it, but the other way might be, if you remember 5 into it was 14.28%, and 28 is 28 into 5, 140, 14 into 5, so this will be 71.4% or 0.714. So probably it helps a bit. 21 by 17, again, if I needed to know 1 plus 4 by 17, and then 588 bus number I remember, and 588 into 4, it's 288 into 4 is 323.36. So 3 and 5 and 4 is 2336. So I think it should be this if I didn't make a mistake. And same with 31 by 13 is 2 plus 5 by 13. And then you can again do it the same way. Get the 13 into percentage, multiply it, and then add it up. So I've just tried to demonstrate how it might help you solve quickly, get to some decimal places. But idly take the fractional part out and then just calculate for that fraction and go ahead and solve it. So my sense was it's helpful. If it's too painful, don't do it. But if you are learning it, then practice it also a bit. Try practicing it in various places. Like write a few examples, just do it yourself. How will I do it? And then check with a calculator if you're getting those numbers correct. And that way you would be able to improve your calculation speed a bit. Such questions come lesser now. They used to be more frequent earlier, but still speed is always good to have. We'll just quickly cover this also. How do you convert recurring decimals to fractions? So recurring decimals are of this sort. So if 0.7 fraction here, it implies this is equal to 0.77777 and it continues till infinity. And same way 0.085 here and the bar is above 5. This means this example is and da 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 da. So how do we convert it into decimal? One way, the other way is easier. Fraction to decimal you can always convert, but decimal to fraction is not straightforward. So we'll just quickly see how it's done. So if x is equal to 0.7777, then 10x can be written as 7.777, so on. And then you subtract them, and since the part after the decimal is the same, you get 9x equal to 7 or x equal to 7 by 9 fraction. And then some people remember it as a result also, like whatever is the recurring part, you just take it and add the number of 9s at the bottom for it. For example, if it were 0.5 this, you will just make it 5 by 9. If it were 0.23, you will just make it 23 by 99. So, oh sorry, I started writing out of the screen. I hope not. So 23 out of 99, but you get the gist. So you don't need to remember the result. It's very simple to derive also. You need to know how it's derived so that if any question comes, you can do it more confidently. If the part which is recurring is not very close to the decimal point but a bit away, you can again do it. So if this is x, first you have to get only the recurring part on the other side. So 100x will be 8.5 this, and then you do the same thing which you did previous. So 1000x will be 85.5 recurring, and so 900x is equal to 85 minus 8, and the fractional part gets cancelled, so it gives 78, and so x is equal to 78 by 900. Unless I made a mistake. I did make a mistake, right? So yeah, so 77 it will be, right? Uh, 77. So I'm just reading the comments right now. So Kim is asking, I wanted to ask one question. I encountered a diagnostic test. Kim, there is no lack of avenues for asking questions. You can ask them later because I needed to cover some material today and those questions might be tough. So, or I don't know, it might be very easy. So we can't handle it offline. Other questions that I can see are just like comments on grade bossy. So that is fine. So if you have got this recurring decimal to fraction, we can move ahead. I don't want to rush through this a lot because this is something which a lot of people haven't been exposed to earlier. So it might be worth spending a bit of time. So through the entire section, I mean. So if you find it fast, let me know. If you want me to stop or explain something again, feel free to voice your concerns and I'll stop and do it again. Just for covering this, I'm not going to spend any time on this, but natural numbers are 1, 2, 3, 4, and so on. Whole numbers will include 0 also. So 0, 1, 2, 3, and so on. Integers would include negative numbers. So minus 3, minus 2, minus 1, 0, 1, 2, 3, and so on. And real numbers will include fractional numbers also. So anything which can be written in P by Q form will be real number. So just to show that you know the definitions, in case you don't, you might be worth opening up a book and seeing them again as well. Properties of prime numbers. So there have been questions asked on prime numbers. So I want to spend a bit of time. There isn't a lot to know. Prime numbers are numbers which have only two factors. So two factors. Generally, that will be 1 and the number itself. Not generally, always the number and the number itself. So 1 and p, that will be the prime number. The only even prime number is 2. 2 is the only even prime number. You guys know that. The part which I wanted to cover was the other part which you should also know is any prime number after 2 or 3 can be written in the form of 6n plus 1 and or 6n minus 1. Now, this is not something magical or there isn't anything fancy going on here. It's fairly basic. If you write a number in the form of 6n, it is divisible by 6, right? So this can't be a prime number. 6n minus 2 and 6n plus 2 can't be prime numbers because they are even. If a number is multiplied by 6 and so it's even, and then you subtract 2 or add 2, it's still even. 6n is divisible by 3, so 6n minus 3 and 6n plus 3 are divisible by 3. And then 6n minus 4 again becomes 6n minus 1 plus 2. So that is not an option because now you are like just going to the previous number and you can just do it this way also. 6n minus 4 will also be even. And 6n minus 5 will be same as 6n plus 1, right? So it's not, there's nothing very scientific, but it might come in handy in some questions. So you should know that prime numbers can be written in 6n plus 1 or 6n minus 1 form. The other thing which I wanted to cover regarding prime numbers is if you wanted to check, let's do it. I think I have a question here on that. So we wanted to check if is 251 a prime number, and the way to check is via is this way. You take the square root of 251. 251 will have a fractional square root. So you take the square root of the number which is closest to 251, and that will be, what will that be here? It will be 15 in this case. So the square root of the number, 251 will have some square root of the form 15 minus point xx and blah blah blah. So if you want to check whether a number is prime, you check whether any number below 15 is a factor of 251. I know you only need to check prime numbers. You don't need to check non-prime numbers, because if a prime number is not a factor, a non-prime number will anyway not be a factor. If you do not understand this, you should think about it, and you would understand this. Why, if a prime number below 15 is not a factor of 251, a non-prime number below 15 will not be a factor of 251. So if I wanted to check whether 251 is a prime number, I'll take its square root, whatever the lowest square root from that number is, as in whatever is the lowest integer for its square root. And here it is 15. So the prime numbers below 15 are 2, 3, 5, 7, 11 and 13. I'll check whether any of this divides 251, and if none of them divide, then this number is a prime number. So 2 doesn't, 3 doesn't, 5 doesn't, 7. I know 251 is a prime number actually. I checked and put it up there, so I don't need to check, but you will need to check, and you check, and that's how you realize whether the number is prime or not. There is the reason why this happens can also be explained. If no prime number below its square root is a multiple, then even if there is no way a prime number above its square root can be a multiple, because and if you don't understand this, don't think about it. Let's assume there is a prime number p which is greater than root 251 and is a factor of 251. Okay, then 251 by p will also be a factor of 251, because it has to be p into something which will make it 251, and this something will have to be less than root 251, right? Because otherwise the number will become greater than 251. So that's why there has to be a factor below the square root of 251. If you do not understand this, don't worry about it. Just know how to find it out, how to find out the numbers. If you do understand it, great. Might be useful. It won't be useful, but it will satisfy your intellectual curiosity a bit. Deepak is taking into areas where you don't want to go. He's asking, sir, complex number is a superset of real and imaginary. Basically, real is it correct? Yes, it is true. As in, a real number can always be considered to be complex also, as in not complex, but a part of that set, because it can be written as the zero imaginary part. And then if you have an imaginary part, you add that to it. Not needed for the exam. Let's look at this. Many questions have come from the stuff. I think the derivation here is also important for you to know. I wanted to cover number system after I do binomial ka jitna bhi karna hai and permutation, combination and all that stuff, because of this stuff. I think it's easier to understand this when you have done it, but we'll try and do it right now also. So number of factors of a number. So any number can be written as by breaking it down into its prime factors. Here we have a number which has been broken down into its prime factors, 2 to the power a into 5 to the power b. And then if you want to know how many factors this has, it can be done by a plus 1 into b plus 1. If the number is of the form 2 to the power a into 5 to the power b into 7 to the power c into 11 to the power d, you can do it a plus 1 into b plus 1 into c plus 1 into d plus 1. You should know how it's derived also, because many times you might need to eliminate and stuff, and then it would be helpful. We need factors of 2 to the power a into 5 to the power b, which means any factor of this number will have to have either 2 to the power 0 or 2 to the power 1 or 2 to the power 2, as in some 2 to the power something below a. And same way for 5. And it will be clearer from example. Let's take an example here. If it's 100, 100 can be written as 5 square into 2 square, right? So its prime factors are 2 and 5. So any factor of 100 would be 2 to the power something into 5 to the power something. And this something has to be less than 2, less than equal to 2. So it can be 0, 1 or 2. And same way this can be 0, 1 or 2. So the number of options that a factor has for powers of 2 is 3, and same way for power of 5 is also 3. It can be 0, 1 or 2, and 0, 1 or 2. And so the total number of factors will be 3 into 3, 9. And that's how you get this plus 1 plus this plus 1. Uh, you can then enumerate factors also, like 2 to the power 0 into 5, 2 to the power 1 into 5, 2 to the power 2 into 5, and then 2 to the power 0 into 5 square, 2 to the power 1 into 5 square, and 2 to the power 2 into 5 square, and 2 to the power 0 into 5 to the power 0, 2 to the power 1 into 5 to the power 1. Sorry, power 0 into. I know a lot of you have already done all this and you know all this, but still we need to cover because some people might not have. So, so these will be the, these will be 0. So these are the 9 factors if you need them. One of that factor is always 1 when all powers are 0. So sometimes you might be asked what would be the factors removing 1, then you just subtract 1 from there. Let's look at the questions. We should have done a few easy ones first. So before you do this question, just do something simpler. So if we were asked how many factors are there for, say, 125, which is just 5 cube. So then you will say just a plus 1, right? 3 plus 1 equal to 4. And those factors are actually 1, 5, 25, and 125. All powers of 5. If we are asked how many factors will 120 have? So 120 is 30 into 4, right? It's 8 into 15, 2 cube into 3 into 5. So 3 plus 1, 4 into 3 to the power 1. So 1 plus 1, 2 into 5 to the power 1, 1 plus 1, 2. And so it will have 16 factors. So that's how you can count number of factors. Now let's look at this question. I'll take a breath. You guys think about how to solve this question. We'll get started. In fact, I will take a 2-3 minute stop here. You guys try to solve this question also if you want. And then we'll continue with this. I think we have important stuff left, 25-30 minutes worth of material left. So won't be very long. So we can take a 2-3 minute break if you guys also want to drink some water or something. So 30 here can be written as 6 into 5, right? So 2 into 3 into 5. You need to know how many factors of this number are multiples of 30. So the number that you are looking for is 2 to the power 7 into 3 to the power 6 into 5 to the power 3 into 10 to the power 5 is equal to 2 into 3 into 5. Okay. If you write it like this, and then you find k out, I'll explain this once it's done. Now all the factors of this particular number that you have will be the multiples of k. So multiples of 30. Let's see what we have done here. We have said that we need to find those numbers which are multiples of 30 and divide the number that has been provided to us, right? And how do we do that? We say that let there be a number k which when multiplied by 30 gets this number. We get k. Now if you get any factor of k, 30 into that number will be a factor of this big number. So any factor of k, so let's say a is a factor of k, then 30 into a will divide the bigger number because it divides k, right? So whatever remains after it, these will be the two factors of the bigger number, of this number. We have taken 30 out and we are finding all the factors of the remaining number. And we say that all those factors multiplied by 30 are the multiples of 30 which will divide this particular number. If you do get this, you should be able to solve the question. So I think some people have already got the answer, so I'm assuming it is the right answer because two people's answers match. So I'll go ahead and solve it. But if you don't, again, think over it, and if you still don't get it, feel free to ask. So this is how we'll again break it down into prime factors. 10 to the power 5 can be broken down into 2 to the power 5 into 5 to the power 5. So that you should remember in such all those formulas. It only works if there are prime factors, not any factor. So 10 should be broken. So it becomes 2 to the power 11 into 3 to the power 5 into 5 to the power 7. And then all the number of factors that this has, which will be 11 plus 1 into 5 plus 1 into 7 plus 1, or 12 into 6 into 8, and whatever it be, unless I have made a mistake. But yeah, so that should be the answer. I haven't made a mistake, right? Because I think I was getting a different answer by people on the page. Yep, 756 is not the answer actually. Yeah, 12 into 6 into 8. So this is how I'll do this. The other part which you need to know about the number of factors. So, and this question is based on that. For a number, we have said that you break it down into prime factors and then you multiply them, right? A plus 1 into B plus 1 into C plus 1. If it's a prime number, then only its number of factors will be odd, because this number will be odd if all these numbers are odd, and all these numbers will be odd if all these numbers, as in A, B and C, are even. And if all these numbers are even, it's a perfect square. If a number is of the form 2 to the power 4 into 5 to the power 6 into 6 to the power 8, it's a perfect square because its square root will be, you just divide it by 2. 2 into 2 into 5 cube into 6, 4. And it's a perfect square, right? So if these numbers are even, then it's a perfect square. And if these numbers are even, then the number of factors that it has, which is a multiple of this, will be odd. And this is the only case in which it will be odd. So it comes to a standard result that only numbers to have odd number of factors are perfect squares. So let's see how it helps us solve this question. We have the first 300. We have the first. I think you cannot see the question. I'll just try and move it. So we have the first 300 even natural numbers. How many of them have even number of factors? So what we know is odd number of factors equal to perfect square. So it's asking even number of factors. So out of the first 300 even natural numbers, which will go from 2 to 600, we need to remove the perfect squares, which will be perfect square of even numbers, because we are only considering even numbers here. And that would mean the 24 square is the closest. 25 crosses 600. So all the even numbers from 2 to 24, right? So 2, 4, 6, so on till 24. And you can count that, remove that from 300. So 2 into 1 plus 2 into 12. So 12 minus 1, 11 plus 1. So 12 numbers will have your odd number of factors. My writing is very bad. Most of you have got used to it now. 300 minus 12 or 288 is the answer that we are looking for in this question. So again, here knowing that result helps. It's a useful one to know that the odd number of factors. You can derive it also on the fly, but if you know it, it saves you a bit of time. It's not very. You can only derive it if you know the derivation that we had before. Let's go through this one also. That was about number of factors that a number has. What about sum of factors of a number? And when we say sum of factors, we mean something like this. So 12 is a number. The factors of 12 are 1, 2, 3, 4, 6, and 12. So the sum will be 16, 12 plus 6, 18 plus 4, 22 plus 6, 25 plus 2, 27 plus 1, 28. So this is a small number, we were able to do it. If it's a big number, how do you find the sum of all the factors of that particular number? So there is again a formula for it. It gets derived from how you sum a GP, how you sum a geometric progression. We will do that later on where we will cover it, but still we are covering it here. So some of you might have studied it. If you don't understand it, again, wait till we cover geometric progression. So this is how it works. Any factor of this number will be 2 to the power some number into 3 to the power some other number into 5 to the power some other number. And these numbers will have to be less than A, B, and C. Right? So these numbers will have to be less than A, B, and C. So these numbers can be between 0 to A, and same with 3 to the power can be between 0 to B, and 5 to the power can be between 0 to C, and this number will be a factor of n. So the way to get all these combinations and sum of all these combinations is this way. You do 2 to the power 0 plus 2 to the power 1 till 2 to the power A. Same with 3 to the power 0 plus 3 to the power B. 5 to the power 0 plus 5 to the power 1, 5 to the power C. And when you will multiply, you will get all the combinations. So when these get multiplied 0, 0, 0, 0, 1, 0, 0, 2, 0, 1, 0, 0, and so on, you'll get all the factors here. So the summation of this will be the sum of all the factors. And you know how to multiply this, as in you would know once you have done geometric progression. But those who have done geometric progression know how to add this. It's a geometric progression where the first term is 1, a common difference is 2, it's getting multiplied by 2, and number of terms is A plus 1. A plus 1. So when you sum it, it becomes 2, 8 plus 1 minus 1 by 2 to the minus 1. And then you multiply it by this sum, which is 3 to the power B plus 1 minus 1. It's again a geometric progression. And 5 to the power C plus 1. So the reason why you need to know the definition here is because the question can be changed. The question can be find the sum of all the factors which are not divisible by 3. In which case you will have to take out the middle term. So then you just take this part out. If not divisible by 3 is there, sorry. If not divisible by 3 is there, you take this part out. And you take this part out and still it remains. If you ask not divisible by 3 and not divisible by 2, then you have to take both of these parts out. And so what remains is this. So this becomes the sum. So if you know the definition, you can make these manipulations on the fly. If you don't, you might find it a bit tricky to do. So that's why it's helpful to know how exactly we arrive at these numbers rather than just learning the formula. You can even make other subtle changes. If the question asks uh, only those factors which are divisible by 4, how will you find the sum of only those factors which are divisible by 4? In which case 2 to the power 0 and 1 don't work. It needs to have 2 to the power 2 and above powers, right? You don't want any power which is just 2 or 2 to the power 0 or 2 to the power 1. So the first sum you will start from 2 to the power 2. This series will start from 2 to the power 2 plus 2 to the power 3 and will keep going till 2 to the power a, and then you will adjust your this formula accordingly. If you know geometric progression, you will know how exactly to adjust this one to give the sum of the series for this particular number, and then you'll still get the answer. So that's why just learning the formula won't help. Here you need to know the how it is arrived at so that you can make changes and adjustments. This one is relatively easier. You can do it yourself. Sum of factors of 120 we've just discussed actually for 1 or 3. You can just write it as 120 is equal to 8 into 15 or 2 to the power 3 into 3 into 5. And then you just need to check the previous formula and apply it. This one is actually trickier. So now we have been given the sum of factors of a number and we need to find the number. This one is not as straightforward. So do you want to take a crack in 1 or 2 minutes? It might be helpful. Why don't you guys try it out? I'll just wait for 1 minute. I won't give a lot of time, and then we'll see how we can go ahead and solve this. I think we have covered most of the content that I wanted to cover in this class. I have a few questions which I want to go through, which are reasonably good questions collected from different places. And I think it's useful. We spent 15-20 minutes. Let me know if you guys are getting exhausted or something. We can stop earlier also because these questions I can get you to give them to you to give them on the group as well. So we don't need to do it live. But I think when you see somebody working them through, it leaves a more lasting impression. That was one of the prime motivations behind doing these live classes. Like when you see somebody like really writing through the solution and telling how it works, the retention is a lot more than when you read it. So let's look at this question. 195. If I try and factorize it, so I know how I get the sum by multiplying the sum. So if I try and factorize this one, this is 13 into 3 into 5, right? 13 into 3 into 5. Now, can we break it apart? Now, it's not very easy from here. So 13 into 3 into 5, the way you get those factors is by doing sums like multiplying these kind of terms, like b square and so, and 1 plus c square. And so can we write it like this? Can 13 be written in this format? Let's check. So 13, can it be 1 plus 2 plus 2 square? Basically 2 to the power 0 plus 1, 4 plus 2, 6 plus 1, 7 and plus 2 cube. No. So it can't be written with as a starting point for 2. Can it be written for 3? 1 plus 3 plus 3 square. Yeah. So this is 13. So 13 can be written like that. Can 3 be written like that? 3 becomes 1 plus 2. So 3 can be written like that. And can 5 be written like that? 5 is 1 plus 2 plus 2 square. No, it can't be. 5 doesn't work. 1 plus 3 won't work. 1 plus 4 we can't do. So 5 cannot be. So then 13 into 3 into 5 doesn't work. We'll have to try other combinations. But we have noticed that 13 works. So we'll try and combine the other two. So we can also write this as 13 into 15. These need not be prime, by the way. So 15, can 15 be written as something? 1 plus 2, we noticed actually it was 15. 8 plus 4, 12 plus 2, 14 plus 15. So this can be written like this. Right? So this can be written like this. We don't need to check 39 into 5 because we know 5 cannot be written like that. So 195 can be written as 1 plus 3 square, 1 plus 2 square plus 2 cube. So which numbers factors is this product representing? This product is representing the factors of 2 cube into 3 square. And hence this would be your 9 into 8, 72. So I think somebody did mention the answer 72, so that seemed correct. I think it's a good question. Checks your grip on the fundamentals and how well you know the formula and how it's done, because you have to go through it from the opposite direction. So revise it. If you don't get it all right now, you don't need to. Later on when you revise, think through and you will get why the answer is 72 and how you could have approached it. Now we have some generic questions. Number n equal to 5 to the power x into y. So there is a number and it's the product of 20 consecutive 3-digit numbers. So if x and y are positive integers, what is the maximum value of x? So we have taken 20 consecutive integers, multiplied them, and we have got a number which is 5 to the power x into y. We need to know what is the maximum value of x. How can we maximize x? It would be easier if you had thought about it, you would have known whether it's difficult or easy. Right now we'll just go to the solution. To maximize x, we need the maximum powers of 5. And since it's a 3-digit number, the 3-digit number with maximum power of 5 is 5 to the power 4 equal to 625. And we'll see a bit more of this in the next class when we'll be discussing number of zeros in n factorial and so on and so forth. There you will get to this concept again. But right now also you can solve this. 5 to the power 4 is equal to 625. 625 is the number with maximum powers of 5 in 3-digit number. So these 20 consecutive 3-digit numbers should include 625. And then you can choose any 20 around 625. It can starting from behind and ending at 625, or starting at 625 and going ahead, or you keep 625 in between. You will get 3 numbers which will be factors of 5. It can be 625 plus 5 plus 10 plus 15. It can be minus 5 minus 10 minus 15. It can be minus 5 plus 5 plus 10, or minus 10 minus 5 plus 5. But you will get only 3 and you won't get more than 3. Yeah, you won't get more than 3. So that means 5 to the power 4 into 3 more, because all these will have only 5 to the power 1 in there. So the maximum value x can take is 4 plus 3 equal to 7. Not sure if it was clear. We have to maximize, we are multiplying 20 numbers. We have to maximize 5 to the power x into y. And we know that the number in 3 digits with maximum number of with maximum power of 5 is 625. So we'll look at the numbers around 625 and around 625 you will get 5 to the power 4 and 3 numbers which will have factors of 5. So that is how we get 4 plus 3, 7. There is no other way to maximize x beyond this. So which of the following are factors of 3 to the power 259 plus 2 to the power 296? I'll move the options a bit to the right. Just to give it a second. Yep. Which of the following are factors of 3 to the power 259 plus 2 to the power 296? Not an easy question. The one thing you need to notice, these are big numbers. When you have big numbers, try and see what can you do with them, how are they related, and so on. So when you start looking at it, I think the difference between these two numbers is 37, and then you will notice that this number will come out to be 37 into 7, and this number will be 37 into 8. So we have 3 to the power 37 into 7 plus 2 to the power 37 into 8, right? Or you can write that as 3 to the power 7 power 37 plus 2 to the power 8 to the power 37. Since it's an odd power, and you know that, you should know that if you don't know, a to the power n plus b to the power n will be divisible by a plus b for odd n. Right? So if it's a cube plus b cube or a to the power 5 plus b to the 5, it's divisible by a plus b. A to the power n minus b to the power n is divisible by a minus b for all n. So this is of the form a to the power n plus b to the power n. So this will be divisible by 3 to the power 7 plus 2 to the power 8. You can check what this number is. This number, I know the solution, that's why I'm like going through it quickly, but you can do it yourself. It will come to 2443. You also need to notice that 349 is actually a factor of 2443. So both these will be divisible. And since it's even numbers added to an odd number, 16 cannot be a factor because this number will be an odd number. So such questions do come. I'm just exposing you to such questions. This is not a time for you to practice questions. The time to practice is when you are practicing, but you get the gist, and some of this will help you solve more questions. So X is a set which has 1, 1, 1, 1, 1, 1, and so on till up to 55 times. T is a subset of X such that sum of two numbers of T is divisible by, sum of no two numbers of T is divisible by 3. So we have taken some numbers out of this set and we have put them in a different bucket. And what is said that if you pick out any two numbers from this bucket and add them, they won't be divisible by 3. What is the maximum possible number of elements in T? Right? How do we do this? So what we know about divisibility by 3 is that if the sum of numbers is divisible by 3, then the number is divisible by 3. When you add two digits which have different number of ones, what you will get is 1 plus number of 2's, right? And those number of 2's will be actually the number of digits in the smaller number. So overall, the sum of digits of the sum will be equal to the sum of digits of the two numbers added. So if I added two numbers which one had 5 ones and the other had 2 ones, the sum of digits will be actually be 7, which is 5 plus 2, 7. So what I need is, so I need to think how to explain this. So the bucket that we create will have items which have 3n ones, items which have 3n plus 1 ones, and items which have 3n plus 2 ones, right? If we add two items, the sum we get is just the amount is equal to the number of digits that both of them have. So we want that to be not divisible by 3. So if we take a item from this bucket which has 3n plus 2 ones And if we take an item from this bucket, which has 3n plus 1 ones, and we add them, the number that we'll get will be of the form 3 into something plus 3, which will be divisible by 3. So that number will be divisible by 3. So we cannot have two items, one from here and one from here, right? We cannot have two items from this anyway, because if there are two items, both of which have 3 n's, then their sum will also be divisible by 3. What I mean here is, if one number has 6 ones, the other one has 3 ones, their sum will be equal to 9, because it will be 2, 2, 2, 1, 1, 1, and so the sum is equal to 9. So we cannot take 2 from this bucket. We can max take 1 from this bucket, and we cannot take overlap these two buckets, right? But we can take as many as we want from any of these buckets. So if we have two numbers which are 3n plus 1 sort, say one has 4 ones and the other has 7 ones, then their sum will be equal to 11, which is not to worry about, and it won't be divisible by 3. So which bucket do we choose? We'll choose the bucket which has the maximum number of elements in there. We are going up till 55. So 3n plus 1, we have 19 items. You can count from 1 till 55. And 3n plus 2 will be 18 items, 2 to 53. So 3n plus 2 has one less item. So we'll take 19 3n plus 1 items and add to it one 3n item, because 1 can be added. 3n plus 1 will not be there. So total we can take 20 items. Maximum we can take is 20 items. If you did not understand, my request would again be the same. Try and think through it. At least I have given enough hints that you should be able to think through it. It will also help you solve such questions in the future. Do not leave it even if you do not understand, because it's not very difficult to solve, or it's not very difficult to understand also. In fact, most of you might have done it if you had done it yourself. So think through it, and then we can discuss if you have some problems still in the future. Okay. This is the last one for the day. Sorry, I don't think we need to. Natural number consists of only zeros and ones. If the number is divisible by 375, then what is the least possible number of zeros and ones in the number respectively? So there is a number, it is divisible by 375. I'll do it. It is divisible by 375. What is the least possible number of zeros and ones in the number respectively? So 375 can be written as 125 into 3 or 5 cube into 3. If a number is divisible by 125 and has only zeros and ones, then its last 3 digits have to be zeros. Think about that. Because if you have to be divisible by 125, the last 3 digits have to be divisible by 125, as 125 does divide 1000. So as we had discussed earlier, the last 3 digits need to be divisible by 125, and the last 3 digits which are divisible by 325 can only be of this form, right? So none of them will satisfy the condition of only zeros and ones except the last one. So if it is divisible by 125, the last 3 digits have to be 0. If it is divisible by 3, then the sum of digits has to be divisible by 3. And the lowest number that we can form by using 1 is just adding 3 ones here. And so the answer will be 111000. So why did we do it like this? We were told the number is divisible by 375. So we prime factorized 375 and we got two prime factors, 5 cube and 3. We checked for the divisibility test of each of them. For 5 cube, we knew that for 125, the number should have the final 3 digits as divisible by 125. And using zeros and ones, the only combination that can be formed was 3 zeros at the end. And by using 3, you only get you need to have the sum divisible by 3, and for that you needed at least 3 ones, so we put 3 ones here. So this is the number. So we'll stop here. from the way our material is laid out, we have covered some of this. We have covered some of this. HCF, LCM, I have not covered. You guys read it yourself. There isn't a lot. You should be able to do it. We have covered factorization. Remainder we haven't covered. We'll cover it in the next session. We'll also cover some more material on factorization. So part of this and part of this will be covered. But you can go ahead and start solving questions in here. Just wait one more day. We are still finalizing the questions and everything, so they should be up there by tomorrow or day after latest. So before that, try and give the number system diagnostic test, and then you can solve these questions. The advanced ones, you can wait 1 or 2 days. Maybe by the weekend you should have these advanced questions also in here, and so you can do that. The weekend will cover the remaining part of number system. I think we have 2 classes next weekend, Friday and Sunday, or Thursday and Sunday, I don't remember. But we will finish number system classes, and then you guys can do all the questions and all the remaining tests. Plus there is an algebra test also, which we are creating, so it should be live fairly soon. Watch out for that. Thank you very much. If you have any feedbacks, let me know. We'll try and look into it. We may or may not be able to act, but we'll definitely try and look into it. Thank you.